Pick up a grain of salt and place it on your tongue. It tastes sharp and solid. Now look at a copper wire, flexible, shiny, and able to carry electricity. Both are made from atoms. So why do they behave so differently? The answer lies in how atoms connect. That connection is called chemical bonding. Let's go a little deeper. Atoms don't bond randomly. They bond to become more stable, usually by filling or emptying their outer electron shells. And depending on how electrons are handled, atoms bond in three main ways. First, here's the most dramatic one. In ionic bonding, one atom gives up electrons and another grabs them. This usually happens between metals and nonmetals. The result is a pair of charged ions, one positive, one negative, locked together by electrical attraction. Think of it like a complete handover. Sodium gives an electron. Chlorine takes it. That exchange forms common salt, hard, brittle, and able to dissolve in water. But wait, not all atoms want to give or take electrons. Here's something even more interesting. In covalent bonding, atoms share electrons instead of transferring them. No one owns the electrons completely. They're shared between atoms. This is how water forms. Oxygen shares electrons with hydrogen. That sharing creates molecules that are flexible, lightweight, and essential for life. Now let's go even deeper. Metals follow a completely different rule. In metallic bonding, atoms release their outer electrons into a shared sea of electrons. These electrons move freely between atoms, holding them together while allowing movement. That's why metals conduct electricity, why they bend instead of shatter, why wires can be stretched without breaking. Same atoms, different bonding, completely different properties. Let's connect everything. The hardness of diamonds, the softness of rubber, the conductivity of metals, the solubility of salt. All of it comes down to how electrons are shared, transferred, or freed. Before we wrap up, think about this. Every material around you, your phone, your clothes, your bones, the air you breathe, exists because atoms know how to bond in different ways. And that leads to the next question. If atoms can bond in these ways, what invisible forces pull them together even when no bonds are formed? Why do some substances melt easily while others don't? That's exactly where we go next, into the hidden attractions between molecules.